Okay, so we're going to be discussing a process here called partial fraction decomposition. Now, I'm going to first explain kind of why it's needed, and then we'll discuss exactly what it is. Um, so, if you consider a problem like this where we have two algebraic fractions and we're putting them together. Okay, so of course, to do that, we would need to build our common denominators. Right, so that would, of course, in this case, be just those two denominators, x plus 3 and x minus 2. So in the first fraction, I already have the x plus 3 factor. I need an x minus 2, so I would put that also up top so that I haven't changed anything. That way, if you were to simplify, all right, that's just still 2 over x plus 3. Okay? And likewise, the same thing with the 5 over x minus 2. We would have to multiply the top by x plus 3. So again, we haven't changed anything. That's still just 5 over x minus 2. Okay? And then we put our numerators together, everything over the common denominator. Common denominator here being x plus 2, x minus 3. Sorry, x plus 3, x minus 2. Got it backwards. So simplifying here, we multiply through by 2. We have 2x minus 4 minus 5x. 5 and 3 is 15. Okay, and so simplifying, we would get down to the fraction here, minus 3x minus 19 all over x plus 3, x minus 2. And we can go one step further here and multiply out the bottom. And we would get this stuff over x squared plus x minus 6. Okay, so this is a kind of an algebra 2 problem where you're putting fractions together, right? And a lot of times, probably in algebra 2, you just told, leave that alone. But here I want to multiply it out. Because here's why we need this process. Okay. Because this fraction here could be written in terms of these two fractions. In algebra, you'd be like, why would you ever do that? Well, we're going to see in a moment why we would want to do that. And the process for doing that, taking something like this and transforming it back into separate fractions, is called decomposition. And so we're going to decompose a fraction like this into its partial fractions. Because here's why we want to do that. So we'll be discussing later on the methods for doing this. That's what it is. It's taking a fraction and breaking it into its partial fractions. Now, why would we want to do that? Well, consider the integral of this thing. Minus 3x minus 19 over x squared plus x minus 6. So the natural starting point here would be to try letting u be the denominator. And in du would call for us to have 2x plus 1 dx. Now I'm going to rewrite that because of how I want to consider things, and say that du is equal to 2 times x plus 1/2 dx. Because then I can go up here and say, okay, the 2 parts, no issue. I just need to have an x plus 1/2 variable part up here. And I can actually do that. I can actually do that as follows. By breaking this up into 2 separate integrals. So the top I'm going to make be minus 3 times x plus 1/2. Okay. And then the denominator x squared plus x minus 6. Then I can do this integral here with straight substitution. I can do this part of the problem with straight substitution. But minus 3x plus 1/2 is not what that numerator was. So I'm putting that there because that's what I need to have there. But I can't just do that because I want to. Right? I have to adjust for it. Okay, so what I've used here to form the minus 3 times x plus 1/2 is I've used my minus 3x. Okay, I've also included a minus 3/2 that wasn't present in the original numerator. So that's the first part of it. And then you would have a second integral, which will involve that minus 19 that's left over. And I have to account for the minus 3/2 that I threw there. And so it actually do plus 3/2. And then that's over my denominator, x squared plus x minus 6 dx. And this one here, we could then work out by using the process of completing the square. Okay, we could then use the process of completing the square. Okay, so that is how you would have to do this problem. Okay, we're going to stop there. I'm not going to go any further. This could be done. This is all just a constant, so that's no big deal. Here again, substitution works out well. We just need to finish it off there. And that part will carry through fine. Okay, here we'd have to complete the square like we talked about in the last section. So that's where you would be at now, is dealing with that. Completing the square process and however that works out. So this would be an awful bit of work. Okay. However, because we know that this minus 3x minus 19 over x squared plus x minus 6 can be rewritten as these 2 algebraic fractions, then that means we can take our integral, and instead of doing all the stuff I just typed, we could take that integral, minus 3x minus 19, over x squared plus x minus 6, and we could rewrite that as the integral of the original 2 fractions, 2 over x plus 3, minus 5 over x minus 2 dx. And those are 2 very easy integrals to do because we just let u be the denominator for both of them. And this would just be 2 ln absolute value of x plus 3 minus 5 ln absolute value of x minus 2 plus a constant. And so we get a really easy result, which would be equivalent. May not look exactly the same, but it would be equivalent to whatever we get when we do all of this stuff. Okay? It'll be equivalent. And it may not look exactly the same, but trust me here when I tell you that it will be equivalent. It will be equivalent. May not look exactly the same, but if you did enough manipulation, simplifying, it would work out. Okay, so this is the idea behind why we want to be able to take fractions like this and rewrite it as fractions like this to give us an easier integration process. Again, we can do it as it is right now, but really kind of hard. And as soon as I go in here and if I put an extra factor on this of an extra x, okay, then we're kind of out of luck. Then we're kind of out of luck as far as trying to go through and do stuff now. We're probably going to just be totally out of luck if I made that x is another factor in that denominator. Okay. But this process of breaking stuff up that we're now going to learn about will let us rewrite these things into a format that we can actually integrate generally not too bad. And so that's the idea here. We can do this, or we can do all this ugly stuff. And it turns out the work involved to take something like this and turn it into something like this is generally less than all of this. And again, it's not even that. There's some that we couldn't do. We couldn't even do if like I said, if I had an x cubed factor there in the bottom, then I don't even know where I would go from there. What I would even do to try to work those out. I'm able to do the square one because I can complete the square and rewrite that and do trig substitutions on it. But with the cube there, then we wouldn't even have a way forward. But with this partial fraction decomposition stuff we're going to learn about, we will have a way forward.